Hi students, in this video we're going to look at introducing arithmetic sequences. Right, so after watching this video you should be able to define arithmetic sequences, determine the first term, we call that T1, and the common difference of an arithmetic sequence, and then express an arithmetic sequence in its recursive form. Right, now before we think about arithmetic sequences, it's actually worth wondering what is a sequence anyway. A sequence is any set of items that basically follows an order or a pattern. So each of these examples all follow a pattern. Looking at this first one, each term goes up by 4 as you go. From 1 to 5 is 4, 5 to 9 is 4, all the way along we're going up by 4. The next sequence, a little bit trickier to see, it's probably better to see in those first few terms, but we're actually dividing each term by 5 as we go from one to the next. 100 divided by 5 is 20, 20 divided by 5 is 4, 4 divided by 5 is 0.8, and so on. This next series sequence, there's no common number we're adding or subtracting, or there's no number we're multiplying or dividing by to get from one number to the next. But what we can see is they actually are our square numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. They're all our square numbers. So those numbers also follow a sequence. There's a pattern to them. Now this last sequence looks a little bit more interesting, but it's also a sequence too. Notice how the numerators go down by 1 each time, and our denominators go down by 2 each time. So there is a pattern. That is a sequence as well. Now an arithmetic sequence is any type of sequence where the difference, right? So difference, so think subtraction, the difference between every set of consecutive terms is the same. So looking at this first one, the difference between 5 and 1, right? 5 take 1 is just 4. The difference between the next two terms, 9 minus 5, is also 4. And if you keep going, there's a common difference of 4 between each term. Basically, with our arithmetic sequence, is we keep going up by the same number each time, or we keep going down by the same number each time. And that's our idea behind an arithmetic sequence. So this next series is not arithmetic. We've gone down by 50 here, then we've gone down by 25 there. So there's no common difference. This one is not arithmetic, whereas this first one is. There's a common difference as we go along. Now the difference that remains constant, we call that the common difference, and we give that the letter D. D for difference. That's all there is to it. Now, in the first term of our sequence, we call that T1. So T means our term number, and then subscripts tell us what term it is. So usually our superscripts we leave for powers. So T for the 2 at the top, that's superscript, that's T squared, or T times T. T underscore though, underscores are used for notation or describing terms. So T2 actually means T is our term, that number 2 means it's our second term. So T5 would be our 5th term, T17 would be our 17th term, T203 is our 203rd term. So that subscript, that number at the bottom, tells us what term number we're looking at. All right, so in an arithmetic sequence, each term actually depends on the term that came before it. Because like in our example here, we take the number that we had just beforehand and we add 4. Then to the next number, we consider the number we have. Then to the next one, we just add 4. Right? Each term depends on the one before it, which depends on the one before it, all the way back to the first term. And this property, where we depend on the term just beforehand, we call that recursive. And we can write a recursive sequence in terms of how each term relates to the term before it. let's go through this one as an example and do another one on the next page. So, looking at our sequence here, all we're doing is going up by 4s. Okay, between each term, we're going up by 4. 4 is our common difference. So how are we going to write this? We're going to say Tn plus 1 and how it relates to Tn. So Tn is our term that we're starting with, and what we want to talk about is how do we go from Tn, this first term, up to our next one, which is Tn plus 1. Think about it in terms of numbers. If we've got T3, that's our third term, and then n plus 1, that'll be our fourth term. How do we get from our third term to our fourth term? Well, we just add on our common difference, whatever it might be. So to get from T3 to T4, we just add on our common difference, whatever it is, that will get us from our one term, our n term, to our next one, our n plus 1 term. Now for this one here, we can say Tn plus 1 is equal to our nth term, or the term we're looking at, and then we add on another 4. That's all we're doing to get from one term to the next. Our nth term plus 4 gives us our next term. Now we're only part way through here because that tells us how we go from one term to the next. It doesn't tell us how we start. So when we write a recursive definition, we can write this rule. That's helpful. To get from one term to the next, we add 4, but we also need to say where are we starting? Well, we're starting at a value of 1. And so if we're starting at a value of 1, and to get to the next term we add 4, well, the second term will be 5, the third term will be 9, and so on as we go. And so this is how we write the recursive form of an arithmetic sequence. All right, let's do an example. Identify which of the following sequences are arithmetic, and for any that are, write its recursive equation. All right, let's have a look at this one. To get from 2 to 1, that's got a common difference of 3. 1 to 4, common difference of 3, that looks good. Or this next one here has a difference of 4. So there is no common difference here. We had 3, then 3, then this falls out of place. So that one is not arithmetic. Even though the next ones are still plus 3, the fact that there's no common difference, it's not the same every single time, tells us that we do not have an arithmetic sequence. Now this next one, we're subtracting 6 to get from 10 to 4, subtracting 6, subtracting 6, subtracting 6. So that one is arithmetic because it's got a common difference of -6. Now how we write that, so we say the next term, n plus 1, is equal to the term we're looking at, and we are subtracting 6 to go from one term to the next one by subtracting 6. And then we also need our first term. We need to know where we start. So T1, that's a comma. Our first term is 10. So starting at 10, we just subtract 6 to get to each next term as we go. And there's our written definition, our recursive definition of our arithmetic sequence. Right, so after watching this video, you should be able to define arithmetic sequences. You should be able to determine the first term, Tn, and the common difference of an arithmetic sequence, and express an arithmetic sequence in its recursive form.